Okay, good afternoon. Thank you, everyone. Thank you for your patience. We're going to go ahead and begin. I want to thank you all for taking the time to attend our webinar, Introduction to SK Series, our overview webinar to introduce our high-frequency solderless compression mount socket solution. We hope you'll find today's 30-minute session helpful in understanding how we can provide the programs you're working on with mechanically and electrically reliable, reusable, high-speed socket solution. Just a bit of housekeeping before we begin the presentation. We do have all attendees on mute, so please submit your questions via the questions box, and we'll do our best to answer the questions during our Q&A session at the end of the presentation. If we're not able to answer your questions then, we'll certainly follow up with you with one of our applications engineers to make sure you do receive an answer. We've also uploaded our company overview and socket series catalogs that you can download at any time from the handout section panel within the GoToWebinar service. And at the conclusion of this webinar, you'll be asked to take a short survey. This helps us gather feedback on how to improve future webinars and webinar content. So please, if you have the time, please fill that out to make sure that we can provide you with consistent webinars that are helpful and useful to you. Lastly, we're aware that many of you are taking time from work right now, so we will do our best to keep this session to the time allotted, and I will be conscious of that as we move forward. So before we begin, I do want to introduce myself as your presenter today. My name is Nat Stevens, and I'm the Director of Marketing for Amphenol Ardent Concepts, and I've been with Ardent for just over 4 years now. And so before we continue, as I mentioned, the company Ardent Amphenol Concepts, I'm excited to announce that Ardent has been acquired by Amphenol ICC, a division of Amphenol, and a world-leading provider of interconnect solutions for the information, communications, and commercial electronics markets. Amphenol Arden Concepts will continue to be led by its management team and will be aligned under Amphenol ICC's mezzanine products business. So this is a very exciting time for Amphenol Arden Concepts as 2018 marks our 15th anniversary, and this investment by Amphenol ICC will allow Ardent, now Amphenol Arden Concepts, to utilize Amphenol's global reach and resources, accelerate the adoption of Ardent's industry-leading products worldwide, and provide a strong foundation for continually developing the most electrically efficient connectors for our core markets. A brief agenda for today's presentation. I'm going to introduce you to Arden Concepts and our patented contact technology. We'll take a look at the SK Series solderless high-frequency sockets. More specifically, we'll dive down into the BGA, LGA, and FPGA sockets we offer, as well as the optical sockets and our Plunge Debord sockets. I'll walk you through some of our lid and cooling options and a brief summary. And as I mentioned, this should take about a half an hour. So our goal is that by attending this webinar, you'll learn how our industry-leading high-performance contact technology delivers superior signal integrity and allows for the rapid testing of multiple integrated circuits using a single socket. You'll see how easy it is to install, remove, and reuse our sockets across multiple programs thanks to our solderless compression mount technology. And you'll learn about how our sockets can So Arden is dedicated to finding creative and effective solutions for the challenges and demands encountered by engineers as they seek to create the world's fastest, highest performing electronic systems. The most fundamental piece in the design of the SK Series is the utilization of dual-sided compression mount technology for a true all-around solderless solution. Our dual-sided compression mount technology is at the core of all of our designs, and it brings many of the benefits to the test and measurement field. It's really unlike anything else on the market. Ardent's designed and developed a compression mount contact from a single wire form, and this happened more than 14 years ago. Our compression technology is a low compression force solution, which requires compressive loads within familiar ranges similar to that of a pogo pin. The ability to offer these low compressive force contacts allows the sockets to be used on a variety of PCB materials, including some softer high-speed materials, including flex PCB. This contact family is known as the RC spring probe and comes in a variety of form factors and is capable of up to 70 gigahertz performance in certain configurations. As is visible here, the RC spring probe acts similar to a compression spring in that when axial force is applied to the straight portions of the wire form, the coil in the center compressions similar to a solid state of a compression spring. In addition to compressing the coils together, the unique angled feature allows the coils to also wipe against each other. This wiping motion can also aid in reducing debris and oxidation. Our other patented contact step below is our RC connector. and that operates in a slightly different manner. The entire contact acts like a system of cantilevered beams, and when axial compression is applied to either end of the contact, the horizontal beams deflect and compress. So when those beams deflect, and the lance there that protrudes from the end of the beams comes in contact with the next lower beam. Again, we see a wiping motion occur at the contact point of the lance to the beam. During the wiping motion, we also get a twisting motion at rounded point of the contact. The twisting motion provides the added benefit of wiping the contact pad of the PCB and provides an oxidation scrubbing effect. So the culmination of this unique single element contact technology allows for a very short compressed contact, and that short electric length allows for superb signal integrity and performance. So along with having a very short electrical length, the shorting method of the contact compression technology produces a contact with low self-inductance, which is balanced by the dielectric values of the housings, to produce an electric interconnect with controlled impedance of 50 ohms. We use both of these contact sets in our socket designs and encourage you to speak with us to determine which contact set is most suitable for your application. So when we look at our SK series compression sockets, a pretty simple description here is that engineers and test environments are focused on sockets that offer high performance at a reasonable cost. So our patented compression mount contact technology, which utilizes those industry-leading alloys and for a cost-effective and electrically robust socket solution. With design supporting pitches down to 0.4 millimeter and speeds up to 40 gigahertz, Ardent sockets are being used with cutting-edge LGA, BGA, other small form factor IC applications in industry-leading electronic systems. With cycle lives of thousands of mating cycles, the electrical repeatability and reliability and performance of our sockets can meet the most demanding application needs. So again, the key benefits you're going to see with our sockets are that durable 40 gigahertz socket solution, which offers low loss connection for high-performing devices. We offer variable package sizes and support up to 70 by 70 millimeter packages today. Our sockets can be easily installed and removed with just a few screws, and that will encourage reuse across your board revisions. And custom mounting and tooling, package alignment, lid, and cooling options are available for even the most challenging application. And those typical applications that we support, your BGAs, LGAs, ASIC, and FPGA packages, optical engines, butterfly gold box packages, extremely large form factor network switches, and also some digital signal processing ASICs and mil-aero environments as well. So how do we do that? How do we support you with these sockets? We use our custom design services. And so we have a dedicated design engineering team who are going to work with you to make sure we meet your design specifications, ensure that your bandwidth and performance goals are met, offer a variety of materials, and gain approval of design before release to production. So at Ardent, our engineers bring novel approaches to solving even the most difficult socket challenges by working with customers to identify their electrical and mechanical needs. So when you're ordering a socket with Ardent, customers have the option of specifying their own footprint. And with the SK family of sockets, our design engineers have extensive experience with designing our sockets to meet those existing customer PCB layouts. Our SK family sockets can also be offered with a variety of materials to suit your application. So for some extreme temperature environments, for example, we've offered all metal variations of our products. For electrically sensitive devices, we can offer sockets with ESD-safe materials. And as a standard, however, we do offer Ultim 1000 for our RC Connector suite of contacts and Vespel for our RC Spring Probe suite of contacts. Throughout the design process, our team will provide drawings and technical specifications in working with your team on board layout and keep out restrictions. No design is released to fabrication without the approval of our customers for the design. And that's a key component in making sure that we produce a socket that's going to fit your application needs. So let's talk a little bit about the form factors that are typically offered by Ardent in the socket category. And I'll dive into each of them a little bit deeper. But again, we support BGA and LGA sockets, optical devices. Plunge Debord is another way in which we support those optical devices. And we'll take a look at exactly what that means. And then our QFN and QFP socket business, with respect to that, we've actually teamed up with Cohu SEG to be our channel partner for our QFN, QFP, and MEMS socket product line. Many of you are probably aware of Cohu's global footprint and vast experience in production ATE. We're incredibly fortunate to be working with Cohu and a team of engineers around the world. And with that said, we had a quick look at the electrical specifications of our sockets, and they do vary by package type. But in this case, really the important things to note are that we can offer 0.4 millimeter and above sockets in grid array. Our socket's frequency range goes beyond 40 gigahertz, and we do have customers using it at that bandwidth today. Typically, insertion loss is at -1 dB at 40 gigahertz at a 1 millimeter pitch socket, and return loss at -15 dB at 37 gigahertz at a 1 millimeter pitch socket. Self-inductance of 0.5 there. So one other thing to note, we do have AC characterization reports available upon request for our contact set, so you can ensure that our contacts are meeting your environment's needs. And we'd be happy to share those with you. Just feel free to reach out to us at the end of the presentation. So with respect to our BGA, LGA, and FPGA sockets and the packages they support, we find that customers come to us with a lot of typical constraints that they're facing in their projects. And that can be things like a lead array of over 2,000 leads, so a very big package. They could be dealing with high heat or high power. It could be an issue with speed, where they may have to have 56 gigabits per second per lane running through their sockets. It might be that they're working at a tight pitch. Something like a 0.8 to 1 millimeter pitch is pretty standard that we're finding. And there's other engineering design challenges as well. So they're always looking for, engineers are always looking for alternatives to soldering directly to the PCB during test. You know, obviously, if you have to solder a package to the PCB, either you're going through a reflow or you're doing a board revision and throwing that PC away, or that PCB away, and that can be an issue. So the benefits and what Ardent sockets bring to the table are a solderless compression mount solution. So all of our sockets are compression mounted with mounting and tooling and hardware, so dowels and screws. And what that allows you to do is remove that socket during a board revision and place it on a new board. So you're not having those lost components. So it's a reusable socket. It's field replaceable. So if there's an issue in the field where you pump too much power through a socket accidentally, you can go in and field replace those sockets. 56 gigabit plus operation. So we're utilizing our patented contact sets to get you high speeds. A temperature range of -50°C to 125°C. So we're used in some pretty extreme environments. And customers are currently using our sockets up to 350 watts today. So that's something that we're seeing as power requirements are increasing with their larger packages transmitting more data. We can submit those higher powered sockets. Up to 10,000 mechanical cycles. So we're ensuring that you have a robust solution without signal degradation over time and over cycling. We offer you specialized lid design force package and PCB flats to ensure an optical contact. So we'll help you with all that design and the lid design to make sure that that compression force is exactly where it needs to be. And we have an average compression force of about 25 grams per node. And we have a multitude of lid options for any of your any budget or any application you're working on. So depending on the solution you're looking for, we can work with you to design the lid that fits best for your application. And we'll take a little bit more of a look at that a bit later. So I did just want to give you a sample breakdown and drawing of a standard lid layout, or excuse me, BGA socket layout that we have. In this case, we have our lid, which could be a lever lid, screw down lid, clamshell lid. We can help you out with a heat sink and a fan or thermocouple. Those are all optional add-ons that we can place there. And then the socket itself is designed to meet the layout and dimensions of your package. And there's an optional slip sheet available for BGA packages. The guide plate is an important piece which ensures the optimal pressure on the package and ensures alignment of your package to our interface and our socket. And then what you can't see in the diagram on the right, but there's actually a picture here on the left-hand side, is we do have a board stiffener as well that goes on the bottom side of the PCB. And so that ensures planarity of the socket and make sure there's no board flex for issues with the socket itself. So we do have a brief video here that we just wanted to show you, which is just a sample connection of the lid to the socket itself. You'll notice that on this picture here, there's actually alignments for the lid and connection of the lid on all four sides of the socket. That allows you to rotate the lid anyway to avoid maybe high components or connections coming off the board. So as you can see, when this socket comes in, you're just aligning the little legs of the socket, sliding into place, and then actuating the lever. So again, a very, very simple way of connecting our lid to our socket design and ensuring optimal process. We want to make it as simple to use our products as possible. So the next type of socket we'll talk a little bit about are our optical sockets. And so we found that the deployment of new backplane systems with high-speed optical modules have presented design challenges for large server systems and manufacturers. With higher node counts, tighter pitches, concerns about power consumption, pushing the need for better, lower resistance interconnect solutions, we're finding that computer makers need to build field serviceable, upgradable options into their advanced server systems. So our optical sockets give customers the flexibility to swap out the optical devices, which prevents significant downtime and prevents costly system rework by enabling a solderless device to board connection. And so in this case, those constraints that they're facing are in something like a gold box ICR package, a butterfly package, which you might find there on the top right for an optical modulator driver, or even a coherent receiver. Those leads, when they go to test those devices, are very fragile. And so they're looking for a way to test a lot of high-speed lanes in a simple package and in a way that doesn't damage the device. And so, oftentimes they're also facing a very, very tight pitch down to 0.4 millimeters. Engineering design challenges. So traditionally during design, those leads are individually soldered to the board. So during design, they're actually individually hand soldering those leads to the board. And that's obviously time consuming. And there's a huge opportunity for error when you're talking about, pitches down that low. And there's production test challenges. So beyond just the design phase, there's unreliable socketing solutions for leads that fragile. The need to test components at different stages and optical alignment for DC test has also proven to be difficult. So the benefits of Ardent's optical sockets here are that we offer you a solderless compression mount solution that's reusable. Again, it's field replaceable and gives you that 32 gigabit per second plus operation using our patented contacts. We can use ESD safe materials. We're suitable for medium volume production test, and advanced materials are used to guide those fragile leads into proper placement. So on the right-hand side here, you can see that there's actually some guiding channels, and then we have our contact located below a contact element. And what that does is actually allows the device, the thinly leaded device, to ease into position into our socket solution. And then if we go to the next slide here, we can look at quickly a quick diagram of what that really looks like for those packages. So they sit on top of an insulator that houses our contact sets, and then a simple clip-on lid can be clipped on to ensure compression and allow for ease of test. So these are solutions that are being used in medium volume production tests today as a way to mitigate those very, very fine leads and easily damaged leads. The next socket here that we're going to talk about is our Plunge to board socket. So this is also for typical optical devices, but these butterfly packages, and this is for leaded devices down to a 0.5 millimeter pitch. Again, the benefits here and what we do with this device are very similar to our other optical device. However, in this case, we're not actually using any of Ardent's contacts. So, these sockets are utilizing Ardent's mechanical design expertise to provide customers with a non-permanent test vehicle. The electrical performance of these sockets is as good as or better than direct attach, and is largely a function of the PCB design of the customer. So we have customers using these sockets today out to 56 gigabits and beyond. And this next diagram that's on the next slide here is actually going to show a little bit about how this works. So in a socket like this, the leaded devices actually sit in an insulator that guides those pins directly to the PCB footprint pads, so that we call them combs. And then in this case, that unique lid design individually compresses each lead of the package from the top. So the lid is actually what's making the compression of the leads to the PCB footprint, and it ensures a reliable and consistent package while making sure to not damage those very fine leads. So it's a really pretty novel approach to making sure that you can test these leads in a scenario where they're direct attached right to the PCB. So, now that we've talked a little bit about some of the basic socket designs that we work with, our typical applications, it's important to talk about how compression is made for operation and test of those designs and our variety of lid design options. And so with that, in the next slide, we're actually going to look at our custom design services sample lid options. So in this case, what's pretty typical for us, we have a standard set of lids here, screw down lids, which are ideal for static applications where the device won't be removed very frequently. It's a very simple design, and it can be solid or open top. if you wanted a thermal solution in there. Clip-on lids, so a quick and reliable attachment and detachment of a lid, and this is really ideal for very small ICs. Our standard bale lever lid offers uniform compression for packages up to 70 by 70 millimeters. So we're using this lid on some very big network switches, for example. And with that, we can design in custom thermal solutions, this is ideal for high voltage applications as well. And in this case, we say up to 250 watts. And then we can, as I mentioned, help you out with custom thermal solutions. So if you're going higher than that 250, we can offer you things like heat sinks and fans, copper blocks, liquid cooling, and high voltage heat dissipation. So tools to help you with that. And we also can connect you to some other companies as well. And one of the things I did want to show you is actually a kind of a fun new design that we very recently released for a customer of ours that just kind of points out our custom design services and the breadth that we can offer you of support in your new applications. In this case, the customer did not want a lid that detached from the socket. They were very concerned that in their test environment, those lids could be lost. And so what we did is we designed the socket here, which actually mounts to the socket itself and uses a hinge system and a lever system in order to compress the package in the socket. So in this case, it was a 292 lead, very small BGA package. And what's really, really unique is this actually has an open top for a thermal stream. And so the lid mounts to the socket frame and then locks in place with that latch. So the compression is made when the lever is depressed. So again, utilizing that same kind of mechanical expertise that our design teams worked with on multiple sockets to kind of have a mix between a bale lever lid and a hinged lid. So in summary, just want to kind of look at this concluding the presentation portion of the webinar. I think as I look at the time, we're right on schedule for finishing up and looking at a couple questions. But I did just want to offer a brief summary of the key takeaways that we've discussed today. Our sockets address the most important aspects of performance in the testing environment: signal integrity at high bandwidths. So our durable 40 gigahertz plus socket solutions offer low loss connection for higher performing devices. Support for even the most challenging packages and applications. So with support for package sizes up to 70 by 70 millimeters, for harsh environmental areas, and for multiple lid and base design options, we have a plethora of solutions available for you. And the odds are, if you come to us looking for a socket solution, we can go through our database and find a similar application we've supported. Cost control. So as I mentioned, our sockets can be easily installed and removed with a few screws, and this encourages reuse across board revisions. Our durable socket solutions offer low loss connection for wireless devices, processors, FPGAs, and other high-performing devices out to 40 gigahertz and 32 gigabits per second optical. And our patented technology decreases board wear, and our all-metal contact solution set is unique in the industry to create lateral translation on the device under test while preventing board wear. So what this means is that our test sockets are highly reliable for hundreds of mating cycles and thousands of mating cycles with zero degradation in signal integrity. And so with that said, we certainly hope that you'll reach out to us with your socket needs. We haven't covered nearly all of the sockets that we've produced and types of sockets and solutions we've offered. We wanted to use this as a 10,000-foot overview to have you come talk to us more about your application needs. And so we certainly hope you'll reach out to us certainly visit our website at www.ardenconcepts.com, which can be found at the bottom of the slide here. We'll also send you a follow-up survey, as I mentioned, and feel free to email us at info@ardenconcepts.com with any questions you might have. So with that said, I'll try and jump into the questions portion of the segment with the 5 or so minutes we have remaining. And so I'll get to the first question I have here. How do I install the socket to my PCB? It's a great question and a very basic question that I think that we should answer here. So in order to install the socket to your printed circuit board, essentially what we use is dowel pins and mounting hardware. So screws and pen nuts, for example, or a stiffener on the bottom of the board. And so you'll simply line up those dowel pins for the socket to fine align the socket to your printed circuit board, and then gently place that socket down onto the PCB. So there should actually be a mark on the socket itself to help you orient the socket to the PCB and identify where to mount it and which direction to mount the socket. And so once that socket's placed on the PCB, you want to hold that stiffener that we talked about earlier under the PCB where the socket is, and then use the mounting hardware to screw it into place. and you don't want to apply too much pressure at one time on one specific side. So start by diagonally screwing in the screws and then focus on the other 2 diagonal screws. And again, as I mentioned, it's typically 4 screws. Okay, next question here. Again, what are the mounting and tooling requirements of the Arden socket series? So in this case, again, as I mentioned, you basically need a minimum of 2 locating dowel pins and then 4 mounting screws. And depending on the package size, that you may require more than that, but that's at a minimum what we look for. So does Ardent have the ability to interface the design with our already purchased thermal units? Yeah, that's a great question. So Ardent has worked with companies, to name a few, Chroma ATE, Sub-Zero Unit, Silicon Thermal, Mechanical Devices. These are all groups that we've worked with and we're more than willing to work with to interface the design of our sockets with their previously designed thermal units. So that's a pretty typical application for us, and it's a solution that we've certainly offered in the past and are happy to continue using. So what is the max power handling capabilities of Arden sockets? Again, another great question. I did kind of say that we worked at a couple different wattages there. So the sockets as they're designed today, Ardent concept sockets designed in-house here are capable of handling 200 to 250 watts. But when a customer requires more power to be run through, that's actually when we'll use those groups I just mentioned, the Chroma ATEs and the Sub-Zero units, to help design a liquid-cooled solution. And we'll work with those outside vendors to do that. And as I mentioned, we have a current socket that we have in a customer's lab right now that's running at 350 watts. And they're working with us actually to jump higher than that as well. And then, this is a really good question, and I'm glad it was brought up. How do your sockets accept and align the solder balls of the BGA packages? That's a really good question, and there is a bit of a difference between our BGA and LGA sockets in that the design is fundamentally the same. We use the guide plate dimensioning of the sockets in the LGA sockets to align the contacts of the device to the pads or the contacts in our sockets. With a BGA, that's a little more difficult, obviously, and so when it's a BGA device, it's imperative that those contacts land, really, really close to the peak radius of the solder ball. And to do this, we actually use a slip sheet. So it's a very, very thin piece of plastic that's a slip sheet that captures those solder balls and fine aligns them to the contact set in our interposer. And so in these BGA socket designs, the guide plate isn't actually used to guide the device under test. It's more of a coarse alignment, and if you were to remove that slip sheet and do nothing else, the device would have a lot of float. And so that slip sheet actually collects those solder balls and helps fine align them to those contacts. And otherwise, there'd be really no guarantee that you're getting the best possible connection there. And so it's a pretty common way we do it, and it's just a very small insert that goes on top of the insulator itself. So with that said, we're up against our time limit. I'm sure I didn't get to some of your questions, and I certainly apologize for that. As I mentioned, we have your questions here noted, and what I'll have is an applications engineer reach out for answers to your questions. Again, if anything else should arise, if any other questions arise, or if you'd like to contact us regarding an application that you have in mind for a socket solution, please feel free to reach out to info@ardenconcepts.com, or you can submit a web request through our website. Thank you for your time today, everyone. We hope this webinar was beneficial for you, and we'd like to continue doing them. So again, please fill out that survey that helps us improve these webinars as we move forward. Thanks, everyone, and have a great day.